Hi, welcome. Today we're going to talk about the first review topic for intermediate algebra, and that's section R-2, numbers and inequalities. And we're first going to start by reviewing what is a set, and a set is a collection of items called elements. Collection of items called elements. So we typically hear the language, and something being an element of a set. Okay, the set of real numbers we represent with this double R. And we're just going to take a moment to review the types of notation that you're familiar with. So one type of set notation is roster, and roster notation is where you have braces that includes the elements. So something like 1, 3, 5, 7. This would be a finite set, meaning those are the only numbers within the set. And then to represent an infinite set, we might say 1, 3, 5, dot, 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 and use the ellipses. Okay, so that's one of the notations that you're probably already familiar with, and the other is what we call set builder notation. And for set builder notation, it's a little more lengthy. So we still use those braces, but we usually have X and then this line, which is read as such that X is a you may have set builder where it says X such that X is a number between 4 and 7. And you can even add more with that, where X is an element of the real numbers, or X is an element of the integers, or X is an element of whole numbers. Okay. All right, the next term we want to define is a subset. And a subset is basically just something that's part of a set. So for instance, the set of natural numbers is a subset of the real numbers, okay? And natural numbers are basically, or what used to be referred to as your counting numbers. So we have 1, 2, 3, 4, on. And of course, we have some abbreviations to represent each of these. And so for the natural numbers, we would represent that with the letter N. Okay. And then under the set of real numbers, we also have a subset, which is the set of integers. Okay. And the set of integers, what's differentiating it from the natural numbers is that it includes negative numbers. And integers, we usually use the letter Z to represent integers because I is taken for other representations, and we'll talk about that as we move forward. Okay, and then of course the set of whole numbers. The only difference between the set of whole numbers and the set of natural numbers is that the whole numbers include 0. And we use a W to represent whole numbers. Okay. So we would say that natural numbers are a subset of the integers, and whole numbers are a subset of integers, and then natural numbers would be a subset of whole numbers. So the subsets have to make sure that they contain the elements, but they can't contain more than the elements that are given. Okay. The next word that we're going to define is rational numbers. Okay, and rational numbers, as you know, are numbers that can be written as a ratio, a repeating decimal, or a terminating decimal. Okay, so all of those are what classify or determine whether or not something's a rational number. Okay, so if we were to look at the following here, it says describe the following and show how each can be expressed as a ratio. Well, this one's already expressed as a ratio Okay, and then we would just call this a real number. Okay, so we would describe that as a real number. And the number 8, we would call that a number of different things. It's possible that we could classify that as an integer. It's also a whole number, and it's a natural number. And we could express that as a ratio using 8 divided by 1. Okay, we have something here with 0.6 repeating. 0.6 repeating, we would say that this is just a repeating decimal. That's how we would describe it. It still is a rational number, and we could say that 2 divided by 3, that could be a ratio that represents 0.6 repeating. Okay, and I mean technically this would be like 0.6777, but this is approximately equal to that. Okay, and then the last one, 0.87, we would describe this as a terminating decimal because it ends, it stops. There's no ellipses and there's no bar over it to represent repeating. And to express this as a ratio, we could say 87 over 100 because this is the tenths and hundredths position, so we could just take 87 over 100. Okay, the next thing we're going to review is irrational numbers. And irrational mean that they are non-terminating and non-repeating. Okay, so some very common examples are radicals that are not able to be simplified or that are not perfect squares, and also pi is our most famous irrational number. Okay, I'm going to ask you to go ahead and pause the video to complete this practice section. So check the sets to which each number belongs. The numbers may belong to more than one set. So -6, we could say that belongs to the set of integers, and that also belongs to the set of rational numbers, and that also belongs to the set of real numbers. Okay, so I'm going to ask you to go ahead and pause the video and complete that set. Okay, welcome back. So the next section that we're going to discuss is inequalities. That's our next piece of review. And I'm sure this is pretty common for many of you. A is less than B, A is greater than B, A is less than or equal to, greater than or equal to, equals, not equals, and approximately equal to. Okay, and we will in class come up with some examples for each, but I will go through at least one of them and you may be able to come up with some examples for the rest. So I just need a number that's less than another number. So we could say, 1 is less than 2. It doesn't have to be anything too crazy. And I'll do the approximately one, and I'm pretty confident that you guys can fill in the rest. So let's say, 11.9 repeating, that's approximately equal to 12, right? Those are very close in terms of their equivalency. Okay, and the last topic that we're going to review today is interval notation. And I'm going to put a little star next to this. Interval notation is really important in this course and all upper level mathematics courses. It's most commonly used to represent solutions. So just to review, we're going to graph each set on the number line and we're going to express in interval notation. So this is saying x such that x is greater than or equal to 3. So that means at 3 we would have a closed circle, is what we learned earlier. And now we're going to use a bracket. So remember, brackets represent inclusion in the set, and parentheses represent when something is excluded from the set. So in this case we have our 3 as our endpoint and infinity as the other endpoint. And so that looks like 3 comma infinity. And since infinity is not a clearly defined point, we cannot have a bracket around it. So infinity and negative infinity will always have a parenthesis. Okay, And then I'll let you go ahead and do this one. Just notice this is greater than only and not greater than or equal to. So this one would have an open circle or a parenthesis. Okay, the last piece is finding graphs for each of these in interval notation. We're going to go ahead and do that tomorrow in class. Okay, so the last thing is just taking a look at translating inequalities, putting words into mathematical terms. So a tropical storm is updated to hurricane status if the sustained wind speed is at least 74 miles per hour. And so if you've been watching the news, we know that there is a Hurricane Irma who is upgraded to that status, and her wind speed sustained is upwards of 150. Last night I believe I heard upwards of potentially 180. So if I wanted to talk about the wind speed of this particular storm, which they haven't identified, they're just saying it was upgraded to a hurricane, then my wind speed would have to be at least 74, so greater than or equal to 74. Okay, so you can always put these things into something that you can relate to. So I always think that I have at least 3 pairs of shoes, which means 3 or more. So greater than or equal to. All right, I'll see you all tomorrow in class. Have a great night.